Vincent, there we go. Okay. Yeah, senior ditch day is the Friday before because on prom on Saturday, people actually have to go and get like whatever you're gonna wear, go get your hair done, go get a haircut, all that stuff that really can't get done. Like a lot of businesses aren't really open on Saturday for stuff like that. So yeah, so that's kind of the thing. That's the reason for, and people go and go do stuff together, not just sit at home and sleep. That's what a real ditch day is actually supposed to be about. Uh, my I know it was a very long time ago, back in Stone Age, when I was in high school. My senior ditch day, we all went to Lake Havasu. Yeah, so there was like a convoy of like 10 cars, and I think it was like 40 people, and my truck was weighted down with a bunch of pallets, so we went to the beach, and then so we were at the beach all day, and then you know had a huge bonfire with pallets at night. So that's cool though, right? That's with a bunch of people that I never really hung out with outside of school. But yeah, anyway. All right, let's see if board working. All right, so we've been maximizing all these things so far in this unit. So now this time we are going to minimizing cost. So one of the things that you got to try and do, especially when you're talking about making and manufacturing, this is one of the things in engineering, which is probably one of the bigger things that a lot of people actually have to do. This is what engineers have to do. Manufacturing needs to produce a cylindrical container with capacity of 1,000 cubic centimeters. The top and bottom of the container are made material that costs 5 cents per square centimeter, while the sides of the container is made from material costing 3 cents per square centimeter. Find the dimensions that will minimize the company's cost of producing the container. So we have two formulas here, right, Vincent? So what's my first one that I'm dealing with here? Cylinder and volume. Okay, so let's start off with that. So I have volume equals pi r squared h. Okay. So there's my volume, but then I also have area. I have the surface area. So I'm going to show you what it's going to look like. So I'm going to take this can, a cylinder. That's the sides. That's the lateral surface area. I have the top here, the bottom here. So as I roll this together, all of it will be contained, right? So there we go. So if I'm looking at just the area of this, I have the area of two circles. We have this area of the lateral surface area. So I know that this is going to be my radius, right? Radius. This right here is going to be my, what do you think that one's going to be? That's going to be my height. That's going to be the height. So if you think about the can, I'm taking my coffee cup for those people watching, my lid, right there. So I have that off, but then the height goes this way, right? And so if I cut it here and unfold it, that's going to be here. And now, right here where the lid fits on is going to be the edge. And so before I keep dripping on myself, okay, this value right here is going to wrap around my circle, right? So that means that's going to be my circumference. The formula for circumference is going to be 2 pi r. It's normally pi times diameter, but I don't want to include a different variable here, so I got that. So I have to add together the different things. So I know for my area, my surface area, my formula is going to be, I have two circles that have an area of pi r squared, plus the lateral surface area, okay? So that's gonna be this, it's gonna be base times height. So that's gonna be 2 pi r h. Where did I get this? Okay, what is the area of a circle? Pi r squared, right? Yeah, so it's pi r squared, but how many of those do I have? I got 2 of them, that's why I did that. So, pi's are always circled, they're always round. I don't know why people keep saying that pi is r squared. Nephi, did you get that one? Pi r squared, but they're not squared, they're circles. But a ting. Spheres are cubed? In spheres they're cubed. Pi r cubed. But isn't it for the area? What's the area of a sphere? 4 pi r. 4 pi r. 4 pi r cubed. Yeah, I don't know. Anyway, but they're not square. So anyway, so bad jokes all over today. Now, couple things that I know now. So let's put in some information. I got my formulas down. Let's put in my information. So, for this one right here, I know that my volume has to be 1,000. So, let's set that up. Let's say, so it's going to be 1,000 is equal to pi r squared h. Yes? Okay. And now, I also know for the cost of the area. Cost of the area. So my area has, so my cost of my area, you know what, I don't like that. I don't, there we go, forward, there we go, okay. So the cost and it's probably going to be pertaining to R. We'll see that in a second. So the cost for this one, it's going to be the top and bottom, which is my 2 pi r squared, because those are my 2 circles, right? And what's the cost of the top and bottom? Was it 5 cents? Yeah, 5 cents. So it's going to be times 0.05 plus the cost of the lateral surface area is 3 cents. So that one right there is going to be 2 pi r h times 0.03. 3 cents for every unit of that. So now before I could do my optimization, my minimizing, my maximizing, I need to actually only have one variable. That's the reason why I say that this as cost of R. So cost of R, that means that I need to use this other formula here to replace my H. So if I do a little bit of algebra here, I could say that H is going to be equal to 1,000 divided by pi r squared. Alright, dividing both sides by pi r squared, it's going to give me my H by itself. Yes? Okay, good. So, let's go ahead and rearrange it now. So I'm going to say that my cost terms of r is going to be 2 pi r squared come on, and this is going to be like that. So now I only have one variable. Now I could actually do my derivative. So my optimization, so C prime of R is going to be, so I can multiply 2 times 0.05, right? So 2 nickels is going to give me 10 cents, right? But when I take the derivative, I'm going to have another 2, right? So that's going to be 20 cents. So it's going to be 20 cents. So 0.20 pi r plus, now before I do my derivative over here, pi's will cancel because I'm multiplying there, and right here, one of those will cancel. So I'm still left with an r to the negative 1 because I have one r left in the denominator. So 2 times 3 cents is 6 cents. 6 cents times 1,000 is going to be $60? Yeah. So it's $60. So 2 times 1,000 times 3, it's going to be 60. But I also have to take the derivative. So that's going to become a negative 60. And that's going to be r to the negative 2 by taking the derivative there. And since we're optimizing this thing, I need to take my derivative and set it equal to 0. I don't know why that keeps doing that. There we go. So C prime of R 0.20 pi R, and this is going to be over 1, minus and I need to have common denominators. So my common denominator here is going to be r squared. So C prime of R equals 20.2 pi, I'm multiplying by r squared, so it's r cubed, minus 60 over r squared. Set it equal to 0. 0.20 pi r cubed minus, come on, minus 60 over r squared. Are we okay so far? Vincent? Okay. Alright, so from here, I now have it equal to 0. So I can go ahead and factor it to find out where my minimum and maximum, my optimization is going to end up at. So I'm going to make a new page here, and I'm going to rewrite this. 0 equals 0.20 pi r cubed minus 60 over r squared, divide both sides by r squared, I'm going to get 0.20 pi r cubed minus 60. Now, I'm going to solve for it since I could add 60 to both sides. So I get 60 equals 0.20 pi r cubed. All right, divide both sides by, let's try this, 0.20 first. Then we're going to have to use our calculator here in a second. So that's going to give me, what is it? 300? So, and divide by pi. So 300 over pi equals r cubed. And how do I undo a cube? Cube root. So r is equal to the cube root of 300 over pi. And I don't know that one off the top of my head, so. I'm going to double check something because something seems right. Yeah, you're right on that. Just not very. So we said control and no, wrong one. There it is. And cube root of Alright, so how do I get my calculator to tell me an approximate answer? Yeah, control enter. So 4.571. What are my units on my radius though? They're centimeters. Okay, so now in this can, my radius is going to be 4.571. Now I got to try and find what the height is going to be too. So I'm going to go back, and my height is right here. So my height is equal to 1,000 divided by pi 4.571 squared. And my height is going to be 15.235. Let's go back to the original question to make sure we're answering all this. Find the dimensions that will minimize the company's cost of producing the container. So when we do this container, that is going to give me the volume of 1,000 cubic centimeters, and it's going to minimize the cost of making this whole thing. So, did you guys ever wonder why cans are a certain size, and all of them are about the same? They're like really the same size? Someone did the math on this. So the whole thing that they're doing is it optimizes the cost to make it versus, you know, the whole production and everything. So, anyway, so they're not just working on the production of making the can, they're also production of shipping it and packaging it and putting it all together. So they have other variables that they're adding to the same thing, but there we go. Alright, I think that is it. Oh, this one here? Yeah, this one here. A rectangle is inscribed in a semicircle with a radius of 2. Find the dimensions of the rectangle that has a maximum area. Alright, this is a good one. I like this one. So, if the radius is 2, that means any point on the circle is 2. So, right here on this circle, right there, I can take this and call that a 2, right? And so, let's try and find where maximizing the area. Ooh, time. What was this?
Les told me to bring it over to you.
Oh yeah. When they actually did our thing, it was missing 2, and so it was weird. So I kind of gave up on it because that was over a year ago.
Yeah.
So we're gonna maximize the area. So let's do the area. Right, the area has to be inside that. So that means that from there, how would I find the area of the circle? Not the circle, I'm sorry. I'll get that one in a second, but the area of the rectangle. What's the basic area of a rectangle? Length times width, right? So what's going to be the area of this one? 2 what? Okay. So, you're saying 2xy. So I have an x here times the height here. Yes? Okay. So my area alright, and it's going to be inscribed in the circle. So, is that a whole circle though? It's a half a circle. So that means that the half circle is going to be, let's see, let's go, my area of the circle is going to be 1/2 pi r squared. Alright, so if we're trying to maximize the area there, let's see, for the area of this circle, do I know what the r is? My r is 2. So my area so that's going to be, area is going to be 2 pi. That's a pi symbol. Faye, you alright? You got these notes, right? The problems that we're working on? No, just the packet. You have the packet, right? Yeah. Okay, I'm just making sure. Because you came in late, so I didn't know if you were still have this. Alright, we're trying to maximize this then. So, what do we know about the area of the rectangle? Is it going to be more or less than the circle? It's got to be less than the circle, right? So I have a certain amount that I can do there. So can I say from here to here is 2? Okay, say that that's 2 right there. And is that a right triangle? And what did we learn the other day about the right triangle? We could do something with Pythagorean theorem, right? We could substitute sides. So I'm going to say that x squared plus y squared is equal to 2 squared. X squared plus y squared is 4. And I don't want to have the y because I'm trying to maximize this one right here, right? So that means I only could use one of the variables. So I'm going to substitute my y. So I'm going to make this into y squared equals 4 minus x squared. Y equals plus or minus the square root of 4 minus x squared. And since we're talking about area here, I'm going to disregard the negative. Can't have a negative area. So let's plug that one in so we could actually do our area now. So this is going to go into my area formula for my y. So I get area equals 2x, and instead of y, I'm replacing it with the square root of 4 minus x squared. Now from there, I'm going to rewrite it before I try to do my derivative because I hate trying to do the radical in the derivative. I like the exponents having the fractional exponent. So area is 2x quantity 4 minus x squared raised to the 1/2 power. And this now turns into a product rule. So my product rule, this is my f and this is my g. My f prime is 2. G prime, okay, it's going to be a chain on this one, so it's going to be 1/2 4 minus x squared to the negative 1/2 times the derivative of the inside. The derivative of the inside is going to be negative 2x. I'm going to clean this up. Those 2's will cancel. So I get G prime is negative quantity for negative x. Sorry. Negative x quantity 4 minus x squared to the negative 1/2. Because the 2's will cancel. So, product rule now. So f prime g, so dA dx f prime g 2 4 minus x squared 1/2 plus g prime, which is my negative x quantity 4 minus x squared negative 1/2 times f, which is 2x, like that. Let's see, rewrite it to try and clean it up. dA dx is going to be equal to 2 still, 4 minus x squared 1/2. This is going to turn into a minus 2x squared, and since it's a negative exponent here, I'm going to put it down here. That's going to have 4 minus x squared positive 1/2. And since we are optimizing, I'm going to have common denominator first. So common denominator, I'm going to multiply this one here times this to have common denominator. So it is dA dx is going to be 2 quantity 4 minus x squared. And when I multiply, I add exponents, so that becomes 2 over 2 minus 2x squared over 4 minus x squared to positive 1/2. So by cleaning that up, it's gonna make it a whole lot easier to do the math. By rearranging it and sorting it out, cleaning up the math. So now as I set it equal to 0, I'm gonna distribute this, so I get 8 minus 2x squared minus 2x squared and zero product rule is going to take care of my denominator. So let's see, subtract 8 from both sides, so negative 8, negative 4x squared, divided by negative 4, I'm going to get 2 equals x squared, x equals plus or minus the square root of 2. So for my dimensions, this is going to be, because it is a coordinate, this is going to be a positive square root of 2. This one over here is going to be going this way, a negative square root of 2, because I'm on the coordinate system. I'm allowed to have the negative on the coordinate system. Now, if I plug that back in to figure out what my y is going to be, y equals, let's see, let's just plug in for the positive because I know that's going to be the same for the negative, just changing the sign. 4 minus square root of 2 squared. That's going to cancel out, so 4 minus 2 is going to be 2, so I get square root of 2 is my y. So that means that this is square root of 2, this is square root of 2. So what does it make this angle right here, if I needed to figure that one out? 45? Yes, 45 degrees, or radian? Pi over 4, yeah. So my x value is going to be square root of 2, and my y value is going to be square root of 2. So, find the dimensions of the rectangle that has the maximum area. Does it ask for the maximum area? It doesn't ask for the maximum area. It just asks for the dimensions. So my x value is right 2, my y value is right 2. Questions, concerns, complaints, conspiracy theories? I think that's the last one, right? Oh yeah. Don't worry about this one because we don't actually do any of the laws of sine. And I'm pretty sure that, yeah, this one's actually not there. Alright, that's it. Make sure you all like, share, and subscribe. Hit that notification button, support my channel, buy stuff from the merch store.